Hello, I'm George Chowdhury. I lead the robotics research at ABI Research, and I'm joined today by Winston Leung, who's a senior manager for robotics at QNX. Hi, Winston.
Hi, George.
So we're here to discuss the state of the robotics market and where it's likely to go in the near and long term. So from my perspective, robotics exists in two places, two markets currently today. We have industrial automation, where it's well established, products have been developed over decades, relationships have been built with manufacturers and the systems integrators who roll out these machines and maintain them, which allows robotics companies to scale and to grow within manufacturing. The newest market, which is burgeoning, is logistics, e-commerce and warehousing. So mobile robots and surrounding methodologies are taking off in force in that space. We want to know today what it takes for robotics to enter into new spaces and new markets. What are the key considerations that need to take place, especially for robotics to enter places like retail, healthcare, anywhere that's a public setting where there's great opportunity for automation to offer value. One of the key technologies that's leading this drive, seemingly, something that's offering a step change in automation capabilities today and potentially opening new horizons for the technology, is AI. So, Winston, from your perspective, how are you seeing artificial intelligence change the nature of robotic systems from traditional automation to more intelligent, adaptive machines?
Yeah, for sure. As you alluded, robotics is becoming much more mainstream. We're entering this new chapter of AI integrated robotics, AI driven physical machines. And a lot of it comes through the vision systems. So you're starting to see a lot of AI integrated with 3D depth cameras, which is enabling a lot of real time perception and analysis. These sensors are no longer passive. They're now in the process of moving towards processing data at the edge, handling object detection, obstacle avoidance, and providing those types of applications where it's understanding the scene without having to necessarily tax the central CPU. A lot of this processing in the past has been done on the main compute functionality, so the main control board. And there's so much data being processed nowadays that you're starting to see a lot of innovations happening at the edge throughout the different peripheral devices. So this offloading is actually really critical for robotics, as we're now expecting these vision systems, these sensors to help navigate dynamic and human populated spaces with autonomy and confidence. We're witnessing this emergence of humanoids and next generation mobile robots that's blending perception, manipulation, and also intelligent navigation.
So, from a market perspective, I think these developments are massively significant in changing the way that we can approach robotics and the opportunities available to robotics for commercial uptake. I think that the technological progress is only one aspect. We also have to consider the fact that robots are so popular within manufacturing because manufacturers know how to interface and how to maintain, how to deal with advanced technologies. They're also very capable at keeping themselves safe. They know how to behave around automated machines that, if they're in the wrong place at the wrong time, could do a lot of harm. Taking these technologies into new verticals and new markets around people that have no prior experience of automation technologies and the damage that a robot could do to the human body necessitates new methodologies and new approaches to safety. So if we look at the new spaces, robots are no longer confined to cages. We need this adaptability and this human-robot interaction. What are the safety implications of this shift into a human-centric environment?
So yeah, as George, you alluded, robots are no longer behind cages. There are offices, there are sidewalks, homes, and hospitals. The old model of safety by separation doesn't really apply anymore. Safety now must be embedded in how robots behave, perceive, and communicate. In the early stages of household robots, the early stages of robot vacuum cleaners, they deployed a bump and go behavior. And this is just no longer acceptable. It's actually dangerous. When these robots carry heavier payloads, or these robots themselves are heavier in nature, they tend to have these behaviors where it could be more detrimental to humans and the surrounding environments in which it operates. So how we perceive it is that we must treat these mobile robots similar to how we treat automobiles. So just as vehicles use turn signals and brake lights to communicate intent, the next generation of AMR should do something similar. In unstructured environments, simple visual indicators like this, like directional lights or projected paths, help increase human situational awareness, thus reducing confusion or near misses. So if you look at this from an AI perspective, if you're doing obstacle avoidance, it's great that the robot's trying to avoid the obstacle. It's even better if it tells you where it's going by avoiding the obstacle, but also telling you where it's gonna move towards so that the human can move in a different direction. This predictability helps build trust. And when humans understand what a robot is about to do, the miscommunication drops and the cooperation between robots and human rises.
Fantastic. Yes, I think it's a tall order, but these are the kind of deterministic technologies that are required if we're to build trust in new robotic systems and they're to take off in new markets. Coming to safety, at the moment, the market is incredibly fragmented. Often the operating system or safety considerations depend on the region. They'll depend on the preferred technologies of the systems integrator. That's both within logistics as well as industrial automation. There's little standardization, and as we all know, there's no plug and play in robotics, but we can introduce some form of standardization to help this market flourish. To you, Winston, what mistakes do companies make when trying to add safety features to robotic systems late in development?
Yeah, so when you're looking at functional safety, it must be built in. It can't be bolted on. That's just not how functional safety works. So when you're looking at functional safety, it needs to be considered from the very start, from the hardware to the software. This includes safe motion control, power redundancy, sensor integrity. These aren't just features, they're preconditions for the operation. At the software level, you're looking at deterministic execution. This is where a certified RTOS becomes essential. In the end, you can't just slap on safety after the robot's built. Retrofitting safety is brittle and reactive, and true safety is designed into the system architecture itself.
I think that makes a lot of sense. Yes. And as mentioned, the added complexity and the lack of determinism is something that is a stumbling block across sort of the emerging automation space. And a safety layer or something that is familiar and universal, some level of determinism in the background is certain to go some way in assuaging the concerns of adopters. In your opinion, are today's safety standards sufficient for the kinds of intelligent robotic systems being deployed now, and what's missing?
So that's a very interesting point because in the past, robots and humans were separated. They're operating in very distinct environments. Robots operate in their own space, humans operate in their own workspace. And now we're starting to see more conjoined operational workspaces. So in these more unstructured environments, a lot of the standards that are moving towards right now are around collaborative applications. In the past, they were known as cobots, but in the future, it's going to be interesting. I think standards must need to catch up with intelligent machines. And when we're talking about AI, they're just not built the same way. Safety standards today are built for deterministic machines like PLCs, but these robots are learning, they're adapting, and they're inferring to the environments around them. The future will probably demand certification frameworks that accommodate probabilistic reasoning, or even some level of situational adaptation or intent signaling. Whether it's a self-driving car or a delivery robot, I think the expectation is the same, that all these robots need to somehow communicate with humans. They need to act predictably in a way that humans will understand them. But the best way to do this is making sure that your systems are built from the bottom up and that you have safety in mind at every step of the design process.
I agree with you absolutely. I think it's a difficult space. This is creating a new market that breaks entirely from traditional industrial automation and breaks from the controlled environments of e-commerce warehouses. It's exciting solving these challenges, and there are lots of innovators within the space who hopefully are pushing the envelope. So, Winston, when I have interviews with startups and innovators and sort of disruptors of the robotic space, a lot of them tell me that it's a very lengthy process to get robotic solutions certified by a regional body like the TUV or UL in North America. What do you think of the significance and the ability to streamline the deployment of products by having certified components in place and ready to go? Does this expedite development time and deployment times?
Yeah, for sure. It definitely does. When you have pre-certified components, it already has gone through the process of the evaluation to determine that it's operating in the manner that it's intended to. So when you're looking at from a software perspective, at least a foundational software perspective, certifying to IEC 61508, SIL 3 gives you that confidence that the operating system is going to perform deterministically and predictably, so that every application or actuation that you do with the robot is going to behave the same way that you're intending it to behave. So when you're looking at it from a software perspective or even a hardware perspective, having pre-certified cost components just simplifies the entire process. You have a safety manual that you can refer to. You start building your application on top of that. And it's basically just building with a pre-architectured infrastructure so that all you have to do is build the end use application.
To my mind, it's this. I know we talk about we can't achieve plug and play, but we can certainly achieve plug and play standardization certification, which seems to be a key building block to building this market out into new spaces. At the moment, it seems incredibly fragmented, and there are so many different approaches and methodologies and regulatory requirements across regions that are, hampering the unified development of automation.
Yeah, it's definitely not a simple task. When you're looking at how robotics being deployed right now, it's being deployed in a variety of different applications, different use cases. And with that, the environment, the HARA, the hazard and risk analysis changes. So even though we want to build these robots for general purpose, general applications, it's not that simple when you're looking at it from a safety perspective, because you have to assess all the risks associated to that. That's why the early stages of robotics was built for single-use purpose-built applications, where you have a designated function that that robot was going to perform. So moving into this new environment where safety is much more complicated, or the environments where it's operating is more unpredictable, it's going to be challenging for a lot of people to certify their robot to address all the risks associated to it.
It's a big challenge. And, it must be overcome if we're to unlock this next wave of efficiency improvements across our economies.
For sure. And that's why working with COTS components, so commercially off-the-shelf components that are already pre-certified, will take you one step further in the right direction.
Winston, thank you so much for your time today. It's been great to meet with you and to discuss these issues. And let's hope for a safe, autonomous future going forward. Thank you.
Thanks for having me.